So we'll be seeing Hungarian problem itself in that maximization type. Till now we saw only the minimization one. Okay, that means minimize the cost or minimize the hours. Okay, all that are minimization type. Now we'll see a maximization problem. Okay, where do we have this maximization concept? Is it for cost? Is it for time? Or is it for profit? Maximization is always related to profit. Okay, yeah, profit. So when the problem is maximize the profit, or when values are given in terms of profit, okay, in such cases, you have to understand the question is a maximization type. So you need to take the matrix as a maximization matrix. Okay, and then you have to start doing it. Okay, but unfortunately, what happens is the steps that we followed, okay, the algorithm, phase 1, phase 2, all those phases, all those algorithm is meant for minimization type problems. Okay, so what do? We have to convert the maximization matrix into minimization matrix, and then we have to solve it using the algorithm. Okay, algorithm means the steps that we saw now, phase 1, phase 2, all that. Okay, similarly in the transportation problem also we had one maximization type problem. No, in the last problem that we solved for transportation problem is maximization. Okay, in that question, how did we solve it? How did we convert the maximization matrix into minimization? You remember? For exam, you have studied, no? In transportation problem, yeah. How do we convert maximization matrix into minimization matrix? How did we do that? How did we do it? We took the biggest value in that matrix and we subtracted all the other values in the cells with that biggest value. Okay, so you will get the corresponding matrix will be the minimization matrix. Okay, hope you remember that. For exam, you had that question, no? Okay, today we'll be seeing the assignment problem, maximization problem, which is solved by the Hungarian method. Okay, we'll see it further. So solve the following assignment problem to maximize the sales. Okay, over here, see, maximize sales. So what value will be given in each of the cells? It is the maximization. Profit values are given in each of the cells. Okay, there are salesmen and there are territories. Salesmen, how many salesmen are there? 4 salesmen are there. Okay, CD, and there are 4 territories. Okay, for person A to travel to territory 1 and make a sales there, how much profit he'll get? 45. Okay, similarly, A is traveling to territory 2. How much profit he'll get? 38. Okay, A is traveling to territory 3. How much profit? 30 rupees. A is traveling to territory 4. He will get 22 rupees. Okay, similarly, there are 4 salesmen and there are 4 territories. Okay, we need to assign each salesman to one of these territories. Okay, territories should not overlap. Only one person should be assigned to one territory. Okay, it should be unique values. Okay, so this is one kind of assignment problem. Okay, don't confuse it with the transportation problem. Don't do that, because over here sales, demand, all those is not given. Our demand and capacity is 1. Okay, one person to one territory. So demand and capacity is 1. Okay, in each of the cells, demand and capacity is 1. The value that is given over here is profit values. Okay, hope it is clear now. Okay, in transportation problem, we have the demand and supply, varying demand and supply values. No, I told that is called as RIM values. Do you remember? So transportation values only you are having different capacities and different demands. Okay, we are solving now assignment problem. Okay, wherein capacity is 1, demand is also 1. Okay, territory 1, they can have only 1 salesman. Okay, so everything is 1. 1 salesman corresponding to 1 territory. So demand and capacity is 1. Okay, so we'll solve it. This is the maximization matrix that is given, because over here it is written maximize the sales. So matrix given will also be maximization matrix. Okay, now what you need to do, identify the biggest number in this. Which is the biggest number in the matrix? Please identify and tell me which is the biggest number. Biggest number is? Which is the biggest number in this? Biggest number is 45, no? Which value is biggest? Yeah, 45 is biggest value. So all the other values from 45. Okay. So here we have the values. Okay. Subtract each of the values from all the values from 45. 45 is our value, subtracted. So you will get a matrix like this. Okay. How will you do it? Here we have 45. 45 minus 45 is 0. Okay. Second value 38. Okay. 45 minus 38, you will get 7 in the last matrix. Okay. Similarly, 45 minus 30 here. So what will be the answer? It is 15. Okay. Similarly, 45 minus 22, you will get 23. Okay. Again, next row, we have 35. So 45 minus 35, you will get 10. Okay. You will get 10. Then again, 29. So 45 minus 29 here, you will get 16. Okay. Similarly, do for all the other values, you will get this matrix. Okay. Now this is the, which matrix? This is the minimization matrix. Okay. After doing all the subtraction, we will get the minimization matrix. What is this matrix? This is the maximization matrix. Is it clear? This is the maximization matrix. The other one is minimization matrix. Okay. Now what will we do? We have to take the algorithm, perform the phase 1 and phase 2. In phase 1, what did we have in the Hungarian method? Phase 1, first of all, you need to check whether the matrix is balanced or not. Okay, here we are having 4 rows and 4 columns. No, here we have 4 rows. A, B, C, D are the row and columns are 1, 2, 3, 4. So we have 4 into 4 matrix. It is a balanced one, so you don't have to worry. Okay. Next, what will we do? Second step in phase 1 is row reduction and column reduction. How do you do that? Row reduction, the same step. Okay, in the first class, what we saw, the same steps. First of all, find the row minimum value. Okay. In the first row, the row minimum value is 0. Second row, minimum value is 10. Okay. Third row, the minimum value is 10. Fourth row, the minimum value is 18. Okay. So subtract each of those minimum values from the corresponding value in that row. Okay. So you will get the row reduced matrix. Okay. So here we have 0 minus 0. Over here, don't put any negative values. Always subtract the biggest value and the smallest value. Okay. So 0 minus 0 is 10. 7 minus 0 is 7. So 15 minus 0 is 15. 23 minus 0 is 23. Next row, what is the smallest value? 10. Okay. So 10 minus 10, we have 0. 16 minus 10, we have 6. Okay. Next, 25 minus 10, we have 15. Okay. Similarly, 31 minus 10, we have 21. Okay. For the next row and next column also like that itself. Okay. Third row, you have to subtract each of the values from 10. Okay. Then you will get the third row, corresponding third row. Fourth row, you subtract all the values with 18. Okay. So you will get 0, 7, 12 and 17. Okay. Is it clear now? So this is row reduced matrix. Now what we have to perform? After row reduction, we have to go for column reduction. Okay. So take this matrix here. The second matrix that is available here, that is row reduced matrix. For this row reduced matrix, we have to go for column reduction. Okay. Column reduction, simple steps. Just identify which is the minimum column value. Minimum column value in the first row is how much? First column value is 0. Okay. Similarly, second column, what is the minimum value? 6. Can you see? Okay. Third column, the minimum value is 12 and fourth column minimum value is 17. Okay. Subtract each of the column values with the corresponding minimum value. Okay. First column will remain the same because minimum value is 0. Okay. Second column, minimum value is 6. So 7 minus 6, then 6 minus 6, 6 minus 6 and 7 minus 6. Okay. You will get the corresponding column over here. Okay. Similarly, the third row, 15 minus 12, 15 minus 12 and 12 minus 12. Okay, you will get 3, 3, 3 and 0. Okay, similarly for the fourth column also. Okay, now we have got the fourth column, we will get like this. Okay, now we have got the modified matrix. Okay, for phase is over. In phase 1, what all were there? First of all, we have to see whether it is balanced. Okay, if it is not balanced, then balance it. Okay, second step in the first phase, that is row reduction. Okay, row reduction. And the third step in the first phase is column reduction. Okay, so first phase is over. Next we have to go for the second phase. In second phase, what all do we have? We have row scanning, then we have column scanning. Then even if the zeros are not completed using row and column scanning, we will go for diagonal scanning. Okay, after all that is over, we have to check whether the number of squares is equal to the number of rows. Okay, if the squares are equal to the number of rows, it is an optimal solution. Okay, otherwise we have to reduce this matrix, the present matrix. Okay, after doing the row scanning, column scanning, and we will get a matrix, right? That matrix we have to reduce it. How will we do? We have to do three operations: copy, add, and subtract. Okay, copy, add, and subtract. If we do all those operations, we will get another matrix. To the new matrix, you have to apply row scanning, column scanning, and diagonal scanning. Okay. Does our solution end there? No. We have to again check for the optimality. Okay. Check if all the squares is equal to number of rows. If it is equal, then we have reached the final solution. Stop it. Otherwise, you have to continue. Okay. So that is our algorithm. Now, where did we reach? First phase we have completed. We have got this matrix. Okay. So next we have to go for the second phase. Second phase, we have the row scanning. Okay. Row scanning. Check the first row. How many zeros are there? Row scanning, how do we do? Check the first row. If there is only one zero, put a square. If there are more zeros, then skip to the next row. Okay, if there is only one zero, put a square and then put a vertical line. Okay, row scanning. How do you perform row scanning? Row scanning we perform like this, no? So when you delete, okay, for row scanning you have to put a vertical line. Is it clear? For column scanning, how do we check? In the vertical, each column we will check, no? So if we have put a square around any of the number there, then how do we delete it? Delete it using a horizontal line. Okay, over here you are using vertical line for deletion. Here you are using horizontal line for deletion. Is it clear? It's okay. So we'll do for first row, we have 1 0 only. So we put a square there and we'll put what line? It is a row scanning. So we'll put a vertical line. Okay, next row. How many zeros? Only 1 0. So put a square there and put a what line? It is a row scanning. So we will put a vertical line. These lines are for deleting those values. Okay. Now, do we have any zeros in the third row? No. Okay. In the fourth row, how many zeros are there? There are 2 zeros, so we will not do row scanning. We will skip it. Okay. Next, go for column scanning. First column and second column, it is already deleted. Go for the third row. How many zeros are there? Only 1 0. So put a square around that. Okay. And then we have to go for the column scanning. So delete it. Column scanning, we have to delete it using a horizontal line. Okay. Next, what do we do after this? What do we do? After this, what do we do? All the zeros are either cancelled or we have a square around it. Our scanning is over. Next, we have to check for optimality. How many squares are there? 3 squares are there. How many rows are there? 4. Okay, 3 is not equal to 4, so we have not reached the optimal condition. Okay, so what do? We have to again reduce this matrix. Okay, by using add, subtract, and copy. 3 operations we have to perform. Okay, which is the lowest value in the undeleted values? Lowest value in the undeleted value, which is the lowest value in the undeleted values? Tell me. We have 3, 6, and 4, right? Undeleted values are 3, 6, and 4. Lowest value is 3. Okay, so 3 has to be subtracted with the undeleted values. That is operation 1. At the intersections, what we have to do? We have to add 3. Okay, and values that are deleted, what will happen to them? They have to be copied as such. Okay, so 3 functions are to be performed. Okay, we'll see in the next slide. See, this is the matrix from the previous step, the first matrix in this. Okay, this is not a optimal solution because number of squares is 3 and number of rows is 4, so it is not optimal. smallest value which is undeleted. Okay, over here 3. Okay, so first of all, what you have to do is at the intersections, just add the smallest value with the intersections. How many intersections are there in this question? There are how many intersections are there? 2 intersections. Can you hear me? Okay, there are 2 intersections. First intersection, the number there is 0. So 0 plus 3, we will get 3. Can you see the slides now? Kanamo.
Yes, ma'am.
Okay. So where did we stop? Okay, we stopped at this slide, right? Okay, here the smallest value is 3. Okay, we have to add this value at the intersections. Okay, intersection, how many intersections are there? 2 intersections are there. So 0 plus 3, we will get 3. And the next one is just 1. So 1 plus 3, it is 4. Okay, 2 intersections are over. Now just copy the deleted values. Deleted values, here we have 0. Next we have 0. Again we have 0. In the first second column we have 1, then we have 0, okay, then again 0, okay. Other than that, two deleted values 0 and 0. So deleted values you just copied like that, okay. Now we have the undeleted values. What we have to do? We have to subtract the smallest value from the undeleted values, okay. So the smallest value we have selected as 3, okay. So 3 minus 3, 0, 3 minus 3, 0, 3 minus 3, 0. Next, last column we have 6, no? So 6 minus 3, 3, 4 minus 3, 1, 4 minus 3, 1. Okay. So this is our reduced matrix. To this matrix, now again we have to go for phase 2, row scanning and diagonal scanning. Okay. So we'll see that in the next slide. Okay. So this is the reduced matrix after copy, add and subtract operations. So row scanning, can we do to the first row? We cannot do it. Okay. Second row, can we do row scanning? No. Third row? No. Fourth row also? No. Because there are multiple zeros. Okay. Again, try for the columns. How many zeros are there in the first column? 3 zeros. So skip it. Second column, how many zeros? 2 zeros. Third column, how many zeros? 4 zeros. And fourth column, how many zeros? We have just 1 zero. Okay. So put a square there. Okay. This is column scanning. So we'll be putting a horizontal line. Okay. Next, column scanning is over. Now again try for row scanning. First row 2 zeros, second row 3 zeros, third row 3 zeros. Row scanning is not possible. Similarly, column scanning is also not possible. Okay, only 1 0 we could cover. Okay, so you can use diagonal scanning. Okay, first row, how many zeros are there? 2 zeros are there. You can select any one of the 0 for diagonal scanning. Okay, so first 0 I am putting there. Okay, what is the meaning of 2 zeros? It means that there are two solutions that exist. Okay. So in diagonal scanning, after putting the square, I have to cancel the zeros in the corresponding column and row. Okay. So in the corresponding column, there are two. So I will cancel it out. Okay. Next again you have to go for row scanning. Okay. Don't go for diagonal scanning again. Okay. In the next row again you go for row scanning itself. Second row, can you perform row scanning? No, because there are two zeros. In the third row, can you perform row scanning? No. Okay, so leave it, skip it. Now again, take the first column. First column. Okay. Yeah. First column, can you do any scanning? Column scanning? No, because there are no zeros. Second column, can you do column scanning? No, because there are two zeros. Third column also no, because there are two zeros. Okay. Fourth column, there are no zeros. Okay. So row scanning and column scanning is not possible. So in the second row, what can you do? You can go for column scanning. Okay. In any one of the zero, you put a square. In the corresponding zeros in the same column and same row, you can cancel it out. So in the column and row, I have cancelled the other zeros. Okay, we have selected this 0. Can you see? Can you see the 0? Okay, we have selected that 0. In the corresponding column, there was 1 0. We cancelled it. In the corresponding row, there was 1 0. We cancelled that. Okay, next what is left? Only 1 0 is left. So you put the square around the last 0 there. Okay, so this is one of the optimal solutions. You will get another optimal solution if you had selected the second 0. Okay, in the first row, if we had selected this 0, then we could have got another one more optimal solution. Okay, so using this, we will check what is the profit values. Okay, so next slide, I have the same matrix in the we got. Okay, so salesmen, how many salesmen are there? 4 salesmen. A, B, C, and D. Okay, tell me the values of territory values. Territory value corresponding to A, which is the territory that he has to go? He has to go to territory 1. Okay, B has to go to territory 2. Did you understand? B has to go to territory 2. Wherever that square is there, no, you tell me those values. C, we have to go for territory 3, and D has to go to territory 4. Okay, now tell me the corresponding hours from the reference table. This reference table is the table that is given in the question. Okay, so I just copied that table over here. That's all. There is no other difference. Same table that you see in the question is written here. Okay, so you tell me the values. Okay, see, remember, you don't have to take the minimization matrix. Okay, minimization matrix we got by subtracting biggest value from all the other cells. We got the minimization matrix, no? But don't take the minimization matrix here. Take the maximization matrix itself. Okay, for finding the, this is not ours. Okay, this is profit here. Profit. Okay, so take the maximization matrix itself because the question is to maximize the sales. Okay, maximize the profit. Okay, so take and tell me the values. What is the profit if A goes to territory 1? Profit is 45. Okay, B goes to territory 2. What's the profit? 29. If C goes to territory 3, what is the profit? 20. If D goes to territory 4, what is the profit? D goes to territory 4, the profit is 10. So we have 10. Now add and tell me what are the values. Here 4 and 10. Yeah, 104. 104 will be the value. So total profit is 104 for us. Okay. Similarly, if you try for the other optimal solution, then again you will get the same value itself, 104. You can try it out for yourself. Okay. For exam point of view also, you can do that. Okay. Some point of view, you will have to solve for 2 optimal solutions. So you can try it out. Okay. So this is how we solve for the maximization matrix. Only thing you have to remember is you have to take the, initially you convert the maximization matrix into minimization matrix. Okay. Last, for checking the answers, again use the maximization matrix itself. Okay. Which is given in the question. Use that matrix for calculating the total profit. Okay. So that's it from this